Hi, welcome to my channel. In this video, I'm going to discuss about the decision trees introduction. So, the decision trees are versatile machine learning algorithms that perform the both classification and regression task, and also even it perform the multi-output task. And also, these are the very important algorithms. These are very powerful algorithms capable of fitting the complex data set. Okay, that means here the decision trees perform the both classification and as well as a regression task, regression, regression task, and also here the decision trees perform the training on the large complex data set, large complex data set datasets. So that's why the decision tree is one of the best algorithm in the machine learning supervised learning algorithms. Okay. Now a decision tree is a flowchart like structure where it contains internal node. It denotes the test on the attribute. It denotes the test on the attribute, and also each branch represents a outcome of the test. Each branch represent a outcome of the test, and also each leaf node holds the class label. Each leaf node contains the class label. Okay. So here we are having, for example, age is one group, age is one attribute, and student is one group, student is one attribute, and credit rating is also one attribute. On this attribute, based on these attributes, we are going to find out the class label, whether the person is going to be found by the computer, yes or no, by the computer, yes or no. So based on these features, based on these attributes, we have to provide the corresponding class labels. Okay, whether the person is going to be by the computer, yes or no. So for that we are going to use the one tree structure. That tree structure is called as a decision tree. So here it contains it is of the form flowchart like structure. It contains internal nodes, branch, and leaf node. We'll see in detail. Okay. Now the topmost node in the tree is called as a root node. The topmost node in the tree is called as a root node, and the internal nodes are represented as a rectangle. Internal nodes represented as a rectangle, and the leaf nodes are represented as a vowel. So there are the three types of representations are there. One is a topmost node is called as a root node, and internal nodes are represented as a rectangle. Leaf nodes are represented as a vowels. And then the decision tree induction is the learning of decision trees from the class label training the tuples. Based on this type of data set, we are going to train our model. Simply this process is called as a decision tree induction. Okay. Now we'll see one example. Here the example is it contains three features are there. For example, age and student and credit rating and corresponding class labels. Our aim is the person is going to be by the computer, yes or no. These are the labels are there. So for that we are going to check the three conditions on different conditions. So here we are having the three different types of attributes are there. Okay. Now on this each and every attribute we are performing the different condition. For example, we are considering the first attribute as a age. If the age is youth age, okay, and middle age and senior age. Based on these three types of categories, we are going to divide them into three things. Okay. So this is called as a condition. Based on the condition, we are going to find out the three actions. Okay. Now, so here based on this condition, okay, now these are the internal nodes are there. So student and one credit rating is there. Suppose here the youth, if the age of the person is middle aged, then automatically he can buy the computer. That means it is a yes. So this is represented in the form of a okay vowel shape. Okay, this is called as a leaf node. It's called as a leaf node. This is called as a root node, and these are called as intermediate nodes. Now if the age is youth age, okay, then we are going to check the one more condition. Here we are taking the other condition like student. If the student, okay, if the person is a student, Okay, if the person is a student, he can buy the computer. Okay, if the person is not a student, then he will not buy the computer. So the leaf node contains the corresponding class label. So yes or no. Okay, yes or no. Suppose if the person is senior-aged people, then at the time we are going to check the one more condition, the credit rating of the corresponding person. If the corresponding person credit rating is excellent, then we are going to buy. He can buy the computer. Yes. Okay. Otherwise, he will not buy the computer. So like that, we are going to construct the based on the our attributes conditions. So here the here three attributes are there. Each are we are going to find out the different conditions on the each and every attribute. Okay. So now, so here it contains three things are there. One is a root node, and internal nodes, internal nodes, internal node, and leaf nodes are there. Leaf nodes are there. Now the root node contains the corresponding represented in the form of a one type of rectangle shape. Okay, and internal node also contains a one type of a rectangle shape, and the leaf node contains the corresponding class labels. So the root node and in the internal node perform the some condition. Okay, the branch contains the corresponding output of the corresponding condition. Okay, so like that we are going to consider the decision tree. So here all the leaf node contains the corresponding class labels like yes or no. Okay, simply this type of thing is called as a decision tree. Okay, now that the decision tree for the boolean functions, we can consider the decision tree for the boolean functions based on the boolean functions also. Every variable in the boolean function like a, b, c has two possibilities, that is true and false. Every boolean condition, every boolean operations are two types. One is true or false. Based on the boolean conditions, we can consider the decision tree. Okay, now so every boolean function is either true or false, and if the boolean function is true, we can write it as a yes. We can write it as a yes. If the boolean function is false, we can write as a no. Okay, if the condition is true, then we can write a yes. If the condition is false, then we can write as a no. Here it will see one example, a and negation of b. First of all, we'll look into the corresponding truth table. So a, b, negation of b, and a intersection negation of b. Okay, so a is nothing but it contains just wait, you read the truth table for this one. Then based on this truth table, we are going to construct the decision tree. Okay, so the truth table for the a and the negation of b is if it is 0, then a b also 0, negation of b, that means 1. So 0 and 1, that is also 0 only, that is the class label is equal to no, and 0 1. Okay, the negation of 1 equal to 0, that means 0 and 0 only, the class label equal to no, and 1 0, negation of 1 equal to negation of 0 equal to 1, that means 1 and 1 okay, that means equal to 1. Okay, it's a yes. Okay, and 1 and in b is 1, that means b negation of 1 equal to 0. So 1 and 0, that means 0, and the corresponding class label is no. So for this truth table, we are going to consider the decision tree. Okay, first of all, we are going to check the condition. So a is one variable, root variable. It contains two values. One is a true value and one is a false value. Okay, so that means if it is a false value, if a value is false, automatically the corresponding class label is no only. The corresponding class label is no only. Okay, if it is true, if it proves if the value of a is either a or either b, the value of a is 1, that means true value. It contains two class labels, one is yes or no. So that means on this condition, on this condition 1 true value, okay, we are going to check the other value, that is b. Okay, that means okay, now if the b is false, b is true, if the value of b is true, the corresponding class label is no. The corresponding class label is no. Okay, that means b is a true value, then corresponding class label is equal to no value. Okay, and if it is a false value, the corresponding class label of b is okay, the corresponding value of b is 0, that means negative. Okay, that is false. Then at that time we are going to get the corresponding class label as a yes. So the class label is a yes. So this is the true decision tree for the given boolean condition. So here based on this truth table, we construct the decision tree. So the leaf node contains corresponding class labels like yes or no, and whereas here the internal nodes and the root node contains the corresponding corresponding attributes. Okay, so like that we are going to construct the decision trees. Here we will see one example of the decision tree. Okay, you should accept the a new job offer or not. Job offer yes or no. We are going to offer the accept the job offer yes or no. Okay, now here we're having the different types of attributes. One is salary at least to $50,000 and commute the more than 1 hour distance and offer free coffee or not. Based on these different features, we are going to consider the decision tree. Okay, now first of all we are looking the first condition is salary at least 50,000 yes or no. If it is no, simply you are declaring the offer. Okay, and then suppose the salary is 50 greater than 50,000, at least $50,000, then the condition is true. Then we are checking one more condition. If the commute more than 1 hour distance, okay, if it is yes, simply are going to decline the offer. That means the distance between the office and work place and your home place, okay, more than 1 hour distance is there, simply we are going to decline the offer. Suppose if the distance is very less, okay, from your office to the your home place, so at that time you are going to check the one more condition, offers free coffee or not. Some perks are there. Okay, if it is offer the some perks of the company by the company, then simply are going to accept the your company offer. Otherwise, we are declining the offer. Like that, we are going to construct the decision tree based on the different conditions of the this attributes. Okay, and here it contains three things are there. One is a root node, and here intermediate nodes are there, intermediate nodes are there, and then leaf nodes are there. The leaf nodes are is called as contains the corresponding class labels, and intermediate node and root node contains the attributes, and here the each attribute performs some condition. Based on the condition, we are going to perform the next action. Okay, like that we are going to construct the decision tree. In the next video, I am going to discuss about the types of decision tree. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.